So this is the radio telescope that we built. It's designed to look at a frequency very close to a microwave oven, around 1.4 gigahertz, which is a very, very bright spectral line in the universe that's emitted by hydrogen that's sort of floating around our galaxy and many others. So the hope was that we could use this to look at our galaxy as it drifts by and see, the spiral arms of our galaxy and things like that, which would be really cool. Unfortunately, like I was saying before, Tucson has 350 some odd days of sunny days, and this is not one of them, which is always the way things work when I'm trying to do stuff like this. And so I guess today is no different. Luckily, however, we're looking at a wavelength of light that is pretty heavily influenced by water, but it's not hard, it's not just opaque. So we actually, earlier today, just 30 minutes ago, Ben and I managed to get a detection of the sun, which is bright enough to just blast right through the clouds, even if the optical, the visible light can't make it through. The radio did. So maybe you should show that.
Well, maybe we'll just show it detecting whatever background noise.
Oh yeah, sure.
So basically, we've got the receiver. If you look under here, you can see a little antenna. So it's reflecting all the radio waves with this antenna. Then these are two amplifiers that we cheated with, and so they would work, but we could probably get something that's reasonably low cost to replace them.
Wow. So there's a spiral antenna that picks up the radio light and basically converts it into something that'll go down a wire. It comes up through the center and into these amplifiers. These amplifiers actually suck. If we had bought some on Amazon for like $20, it'd be better than these, but this is what I could steal from work, so that's what we used. This one actually doesn't even work. That was kind of a bummer.
It did work before I mounted it on the plate.
Well, so whatever. You owe me $20. So the signal gets amplified, sent down this cable, and into a software-defined radio, which is a little
wee thing.
$10 USB TV tuner dongle.
So they're designed for receiving digital TV signals, but if you put a different driver on your computer, you can use it for anything. So anything, you can receive AM radio, FM radio, you can listen to the police traffic if it's not encrypted, you can listen to traffic complaints communicating where they are. We're trying to use it to pick up radio signals twice.
But the cool thing about this is that you can tune it to pretty much anything you want. The whole system, except for my shitty amplifiers, are designed to operate over an extraordinarily broad range of frequencies. So you can point this at satellites, you can point this at radio dishes, you can do anything you want. Just break it.
Oh, it should be plugged into something.
Oh, that might be helpful. And so it's a very versatile thing, not just for astronomy, but for any sort of exploration of the radio wavelengths that you might want. So in the end, the thing that we get at the end, this is just, it's like a camera, but it's only got 1 pixel to it. So it's hard to make nice, pretty pictures with this thing, but what you do get is a spectrum. You get a graph of the amount of energy being received at different wavelengths of light. And it's actually got a whole bunch of resolution there. So for astronomy, the kind of thing that you do would be, so the galaxy is sort of like a line, basically. And so as the galaxy would drift into view, you'd be able to see different areas of the galaxy at different wavelengths of light because of this principle of Doppler shifting. Like, if you ever hear an ambulance driving towards you and away from you, you hear the pitch of the siren change. And so that's because the thing is moving with respect to you. And so that changes the wavelength of the sound. The same thing happens with light. And so as different parts of the spiral arms of the galaxy move towards us or away from us, we can see that change. And so it's pretty much the only way that you can see what's going on with our galaxy, because it's all superimposed on itself. It's all just one giant line. Anywho, you want to show them stuff?
Is it, so we'll show you just what we'll receive when we're pointing straight up at cloud, which will be kind of a background noise. So we'll have a plot of a frequency on the x-axis, and on the y-axis we'll have the power. So how much power we're receiving at that frequency.
Does it matter that the center tube is hollow, or is there any?
The center tube was actually, it was originally supposed to hold this thing, but it did kind of a lousy job of it. So we cut it out. There was another piece here that was easier to remove. This is like screwed in, so we can sit it.
So that doesn't necessarily help with the functionality of it. It's more for structural.
Well, it was an older revision of the structural assembly. Right now, it's just It's just it's cosmetic. It doesn't do anything. Except point at a goofy angle.
And does the shape of this whole mechanism, like, could you just have the tripod with the sensors or something, or is there something else going on that you need
Well,
this whole...
so that's actually a really good question that I should have answered. The chicken wire is a dish. The light that we're looking at is so long in wavelength. The light itself is physically large, and so the light can't actually pass through this chicken wire. It's so fat, and it just gets all the light coming in from the sky, bounces off the chicken wire, and gets focused inwards towards the detector. So this is a way of collecting more light and also getting a sharper spot on the sky.
Cool.
Does that answer?
Yeah, awesome.
So yeah, it's a mirror.
Yeah.
You can take my word for it, I guess.
Would it
Yeah,
be
so
something
anyone wants
different
to
if
head
it was
over here,
actually
we are getting
versus...
measurements.
It would be a little bit more efficient if it was a mirror, like a nice, perfectly smooth mirror surface. It would work a little bit better, but you know, mirrors are expensive. Chicken wire is cheap.
Yeah,
Just aluminum foil.
Yeah, aluminum foil would also be a really good option.
This piece right here.
The nice thing about the chicken wire is that it's kind of stretchy. So when we're trying to get it to form into this parabola, it was a lot easier to do.
Did you guys develop the equations for your parabolic
That's
planes yourself, or did you just like smush that together?
So yeah, basically, you know, the whole thing's laser cut. So I just mocked it all together in Illustrator.
The sun just has a.
It's remarkably easy to run with it.
So we just see this whole.
I just made segments. You know, we cut them all out.
If we could pick it up in the galaxy, we'd see one particular wavelength.
I was just wondering if you kind of
So what we need to do if we want to really see that would
Just jumped really big.
Yeah. So so the lengths should be vaguely accurate. Now, granted, this
I'm not sure how much of that is
this is sort of
scaling.
like not the best thing in the world,
Because our scale changes,
uh,
doesn't it?
Yeah.
So this is notionally
Yeah,
sort of
this
the
is.
right. It's supposed to be about.
The UI is like
The
a...
focus is half of the radius of curvature, and so that's
So this
where it is.
right here is it's in job and
The
processing.
nice thing about this long
Um,
wavelength stuff is that
so-
accuracy is huge.
Yeah, it's just Java.
Okay.
Really, at the
It
end of the
certainly
day.
looks to me like it finally wants to go to
right,
the
guys.
And then let's bring a static. If you go to the compare down there.
It still works. It's not.
So this is a static image, just showing the when we point it at the sun and when we point it away from the sun. So the red one is when we point it at the sun. So you can see all it does is
You know, I wanted to develop.
we're pointing at something bright, and there's emissions from the sun at the whole spectrum range over the window that we're looking at. What we'd like, if we could somehow point it at the galactic spiral, what we would hope to see at one frequency there'd be a peak where you were seeing that hydrogen line, and that's something that we haven't managed to see in 24 hours. It would be nice to get working.
Does it matter if it's at night or day? It doesn't really matter?
No, it doesn't matter.
We etched the spiral. Is
I mean, it might be your background noise.
normal like tone transfer circuit
For the sun, it's going to have to be during the day to get
the dish is, you know, obviously all made. You know, not everyone has a laser.
So you said on the
cutter,
real-time
but we could
display it
cut
scales,
pieces
is
of
that
the
just
available
auto scale,
you know,
based on
like
what
IKEA furniture at all times.
I think it's
Pretty much, yeah. So, so this visualizer, it's waiting. So, on the back end, it's just dumping all this data to a file.
Yeah. So
This is